So I always start thanking my family and my girlfriend. Ciao. And OK, so I'm going to talk about unlocking ASGI innovations, how FastAPI reaps the benefits. So yeah, I'm just going to try to have fun because it's the last talk, and I guess people are tired. So yeah. So let's start with I'm Marcelo. I am. Oh, this is running on a. Well, it's fetching the images, but it's not loading. But anyway, I'm the maintainer of Uvicorn and Starlette. It's supposed to have the icons there. I hope it's the only one that has. Am I without connection here? Well, it doesn't matter. I hope I don't have anything that's not on the repository. Anyway, so what is ASGI? ASGI is the interface that is the one that comes after UASGI, which is the interface that tells how you interact between the application and the server. So UASGI was used for Django, Flask, and Uvicorn, and all those that doesn't use async. And now, since 8 years ago, ASGI was created, and it tells how you communicate between the server, like Uvicorn, and the application, like FastAPI. And that's what I'm going to be talking here. I'm going to be talking about how the changes on that spec give a benefit to FastAPI without FastAPI doing anything. They just get the benefits from it. So again, what's ASGI? ASGI is just this. It defines how you communicate between the server and the application. So it needs to define that in a way so they can understand each other. The server needs to understand the application and the other way around. So you define this interface where you have an application, and then you pass the scope, receive, and send. Receive is used for the application to get information from the server, and send, it's from the application to send information to the server. So it just works in two ways. You receive and you send, as much as logical as it might sound, but you receive certain information from the server, like, for example, you receive bytes from a body, you receive if the server was disconnected, the client was disconnected from the server, the server disconnected from the client, and you send information like the response back, the headers, the body, and all that stuff. The scope, you just have the information about the connection itself. So you get the path, the headers, and all related information that are part of the connection. So why does FastAPI follows ASGI? Well, pretty much it's because FastAPI is a class that inherits from Starlette. So, and since Starlette follows ASGI, FastAPI just gets that. I don't think there was a bigger thought on what FastAPI could do. Like, there was no option because Starlette follows it. And Starlette was created 6 years ago by Tom Christie. And Tom Christie was already involved in the conversations and all on the things related to the creation of the spec itself. The spec has also around 8-9 years. And Uvicorn has 8 years, so it was around that time where Uvicorn was also created. And 2 years after, well, Starlette was created, the server was already being created by the same person, so it did make sense to create a web framework that was also following the same specification. And that's why FastAPI uses ASGI. So now we start, we're going to talk about some features that FastAPI has that not a lot of people know about them. Also because it's not documented in the FastAPI documentation. So I'm just going to briefly talk about them. And those features were introduced in the last 30, 65 days, I would say. So for example, I'm going to talk about the WebSocket denial response, which is a way for you to define which kind of HTTP response you're going to send back to the client when you want to reject the upgrade for the WebSocket. Okay? So, hold on. Okay, so well, who have used WebSocket in FastAPI here? Huh. Install it? Oh, it works. Install it as well. Any WebSocket in your life? Ah, much better. I should have started with that. Yeah. So anyway, do you know what happens if you? Well, no. Let me do a rephrase question. What do you think it happens here if you send? We try to connect with a client on a WebSocket client, and you send a request to this endpoint. Who thinks is going to connect successfully? Okay. Who thinks is going to send a 500 error? Okay. Anyway, so I'm going to tell you. What happens here is that the FastAPI, well, the underneath, the Uvicorn will send back a 403 because you actually didn't have an acceptance of the WebSocket. So you closed before actually accepting it. So since you didn't have the acceptance, then you cannot send a close frame, which is trying to do, send a close frame. That doesn't happen. So it sends a 403. Produção. Cadê? Yeah. So that's what happens. It sends a 403. And it sends a 403 because it was a way for the ASGI spec to say that you need to send some HTTP status code when you close a frame before acceptance. That's what was written there. And then they created the WebSocket denial response extension on the specification. That gets a bit complex, but it's just in a way that you can now choose which status code you can send to the client. So now you can do this. You can do this with FastAPI. This can happen since, I don't know, 3 months or something. So you can define a response, and you can define what you want to send. So instead of 403, I want to send 401. So I do this, define a response, and I send back with WebSocket send denial response. Okay? So that's useful when you want to send back a response and not accept the WebSocket connection. And now, since, well, 2 days ago, since I discovered that this was not possible, I implemented it on Starlette. So it is going to be available on the next FastAPI release that supports Starlette. So we're going to be able to do the same as this is doing, but only sending an HTTP exception. So we're going to, those two are analogous codes, this one and this one, just raising the exception. Starlette underneath will capture this and then send a 401 to the client. And this would be more a practical example on how this would be useful. But you'd have probably this underneath. You would not implement this on each endpoint body. But this would be like, if the token that you're sending to me, like authorization header, is something that should authorize my user, then I accept the connection, the WebSocket. Otherwise, I send back a 401 saying that I don't want. Okay. Yep. Now, HTTP trailers. Who knows what HTTP trailers are? I see a hand there. Thank you. So, HTTP trailers are a way for you, well, for any application to send back to the client some information after the response body or all the data that you really wanted to send was sent already. For example, you can have information about, imagine you are streaming data and you don't know how does the data look like in the beginning, right? So you start streaming data and send data and then sending data and send data, and you have a lot of data to send, the client receives all the data, and you want to confirm that the integrity of the data. So you'd send a header that will have a hash of the whole data, and then you make sure that this data was not modified in the way or something like that. You can also have the server timing response to check the time of the whole request, and then you send this. It's pretty much headers that comes, like HTTP headers, but it can come after the response is sent back. And this is also one of the things that FastAPI supports. Also not very useful, it might be, used. And Uvicorn supports it out, well, it already has its support. So if you do it with, if you can do already with FastAPI, you can send HTTP trailers already. Okay. Who knows what's happening here without me saying it? Haha. Okay, yeah. So, so this is a pure. Thank you. This is a pure ASGI application. This is just FastAPI underneath. It's just the pure spec how it is. So you have on the line 3, you have how the spec defines it to the application. How does it look like? And then you need to send the first message, which the HTTP response start, where you send the stats code and then the headers. And here I'm sending that I want the content MD5 header. And then I send each chunk here. And then I update the, well, how I'm going to calculate the hash. And then I calculate the hash. And then I send the hash back on the trailers. So this is the idea. You send the body, line 13, you send the whole body. Sorry, you send the last message of the body. And then on line 14, you send these HTTP trailers. You can already do this with FastAPI itself. But you'd have to implement it yourself, this last part. So FastAPI doesn't have support for this underneath. I had a pull request on Starlette to implement it, but it didn't go through because it just added a bit more complexity that I wanted to, and it didn't look like there were many people interested on this feature specifically. Yeah, so I had this pull request. It was closed. I opened it. I closed. No one replied anything. So I just, yeah, I closed. But I mean, if someone wants to do something with HTTP trailers, maybe it doesn't have much motivation since, you know, but it's still something you can investigate. Like I found out what this thing was about when I saw it written on the specification itself. So then I learned what it is. Maybe it's only me who knows what it is. I don't know. But anyway, so move. Yeah, anyway, you can create an open source project that supports that on FastAPI. Like it uses the same response classes, like response, JSON response, and you can add these trailers as another parameter if you want. If you want to do some open source or something, I don't know. But then, yeah. So now next feature. This is actually good. Everybody benefits from this. And people actually have faced some problem with client disconnection. Like if you develop with FastAPI for some time, you do have a problem with this at some point. It was historically fixed, some of the stuff over time. People don't notice, but stuff are being fixed. But anyway, so these, again, pure ASGI application. Imagine a client send a request here. So I'm going to explain first. On line 5, you're just making sure that this is a HTTP request or HTTP context. Line 7, I'm sending the first message, just headers and status code. And from line 9 to 13, I'm sending just the bytes of hello world. So H, E. It looks really cool on curl when you see H, E, L, L, O. But anyway, so, and then you have, so you just send those. And at the end, you just send the last message, which sends back, like the client knows that this ended. This is what is happening. But then, what happens if the client disconnects in the middle of this? What if the client disconnects, like I'm on the letter O, on the hello, and the client disconnects? Who thinks this application stops? Yeah, so this application will not stop. So if you just send, well, this application wouldn't stop before. So right now it does stop. Well, actually, no, I'm sorry, it doesn't stop. Let's continue with that, yeah. But it potentially will stop. So this doesn't stop because you have no way, like based on the spec, to know that the client was disconnected. Because with the send message, you cannot know if the client was disconnected. So you just don't know. The client, the spec didn't specify that. you just can only know if you call the receive. What is it? You call the receive, and then you get a disconnected message, right? So this is a bit more complex stuff. But I want you to look at lines 8 to 11, where I create two tasks. One that continues to send the bytes, which is the send chunks, which is the same logic as we had before. And the other is the check disconnect. The check disconnect, if we go to line 14 to 19, I'm just running the await receive, and I am checking if I receive an HTTP disconnect. If I did, I set the stop event, and then it stops on the chunk. That's what is happening. But as you can see, this is complex. And not only complex, but you can have other parts of the application. So for example, if you want to receive data from the client is streaming data, and you want to stream data back to the client. So you kind of receive, process, and send back, receive, process, send back. It cannot happen if you have a task that is checking the disconnect, because it will steal from me the message. So it's really, so if I have a task that's running on the background that's doing the same as I am doing right now, if like two tasks doing the same, then they might steal from me the message from the body that I received. Because this receive does not only checks for disconnect, but it receives the body of what the client is sending to me. So it can happen like, oh, I got the body. No, you got the body. So it's like something you want to avoid. So right now, it's not possible to receive and send, unless you are doing, well, actually, it's not possible. But then, this year, or it was last year, Adrian, a colleague of mine, who also maintains Starlette, he created this amend on the specification. So it says pretty much that when you use the send method, you now receive an OS error exception. Yeah. So now it is possible with the first code that I show you to just raise an exception and the application stops. Okay. Yeah. So this is what's supposed to happen. You have this is the perfect world. So you have the chunks. You're sending it. Sorry. And then you accept. AO error is the same as OS error. Something with Python 2, they make it the same name or something like that. I don't know which one is I think the OS error is the current one, the Python 3. Who knows? Someone knows? Well, I don't know. It's either one was on the Python 2 and then it becomes on Python 3. They change the name. They are the same thing. Anyway, so yeah. So now when you call the send and it was disconnected, then you have an exception and then you get disconnected. But this was actually not implemented on Uvicorn yet. What was implemented on Uvicorn was on WebSockets. So now on WebSocket, if you send text or send bytes or send JSON, you do have the WebSocket disconnect from, well, I think it's from FastAPI as well. It just copy paste from Starlette. It's directly from Starlette. And before, you couldn't do this. So this is just something that FastAPI benefits out of the box. The next step would be to implement on the HTTP part, and then being able to receive from the client and streaming back. Do this streaming back thing. Oh, really? Thank you. He said 5 minutes. Crazy. So next step would be to implement that on Uvicorn. It was actually implemented that I had to reverse because it got a bit more verbose because you were able to actually see when it was disconnected, and people thought there was a problem on that. So there was a bit of confusion, and to avoid the amount of issues that were being created, we reverted because we're trying to smooth that down some way. Well, actually, we're trying is a bit strong. It got stopped at some point, but ideally we would smooth that feature to the users so they could stream in and stream out. Because you sometimes want to just receive the stream, process, and then send back. It's just faster to do this. So that would be the next step, implement on Uvicorn, and then conclusion. Some features FastAPI just gets free, and no one notices. Or maybe no one needs it as well, HTTP trailers. I don't know, it happens. Yeah, it happens a lot. But yeah, hope you had fun with the stand-up, and that's it. Yeah. Oh, hold on. So I have this repository, cluedex/FastAPI tips. Just has some tips. It helps. About trailers, yeah. No, I'm gonna add today. No trailers there. Yeah. And peraí, pô. Oh, you were taking picture? No. Oh, okay. Yeah. Yeah. Samuel's here. Bad boss. So we have a coupon for Logfire. We are from Pydantic, PyCon PT 2024. Use it. And yeah, thank you.
You still have 5 minutes. You only used up 2.
Cala a boca,
That's
rapaz.
fine. Okay, so let's have questions from. If you have any questions for Marcelo, just raise your hand and I'll run to you awkwardly with a microphone. We have 8 minutes to fill up, so come on. One question for Marcelo, please. Yes, excellent.
Thank you for the talk. So with that client error, client disconnect error,
Yeah.
was there any thought on backwards compatibility, or like are people servers now just erroring out every time a client disconnects?
There was. So that's why. Oh, that's why we reverted. Though on HTTP, because on WebSocket, I think it was actually a fix, because on send you were actually having exceptions from WebSockets, like the package, and also from WS Proto. So there were kind of you as a user you don't expect those exceptions. So implementing this was actually a fix on WebSockets itself, because now Starlette can know that Uvicorn sends OS error, and then it transforms to WebSocket disconnect, and then you know. So that would fix, like, there was no need for thinking about the backward compatibility. But for Starlette, it is a bit more complex, because on Starlette, we would need to check the version of the ASGI server that's running. And I know it's the obvious thing to do, but we just never did it. So we don't check the version of the spec on Starlette. I don't know, like, it's just no one, usually the spec never breaks stuff, so we never checked stuff from the, I don't know if it makes sense, but that's what's the idea.
Thanks.
Yeah.